हाँ बस ठीक ठीक स्टार्ट कर दिए. Okay students, in the same lecture series, today we will discuss the logistic regressions. Logistic regression I have divided into three parts because to discuss the complete topic we need three divisions, and if I combine in a single division, so that will actually exceed your the video will exceed, and the time taken by the video will also be means large. Okay, so we'll start the logistic regression, and so the thing is, logistic regression is a kind of a supervised learning algorithm. Okay, so in the previous lecture we have discussed that there were three techniques, mainly three techniques: supervised, unsupervised, reinforcement, and the fourth one was semi-supervised. Okay, so this belongs to supervised learning algorithm. Okay, so but it is called as logistic regression, but it is a probabilistic classification algorithm or model. Okay, it is widely used in binary classification task, where the goal is to predict one of the two possible outcomes. Now if you understand this, a classification problem is where you have to actually group the certain data into class A and class B. So logistic regression is only used to begin with. It is mostly used in a binary classification problem where the response or the output is between yes and no. So yes means you belong to a certain class, and no means you don't belong to a certain class, you belong to the other class. Okay. The interested students can further, after completing this video, interested students can further explore how we can have multimodal classification by using logistic regression. But that is beyond the scope of your current syllabus. Okay, so we'll focus on the binary classification problems. Okay, so this is the logistic regression. Okay, so remember, whenever there is an we have to respond between yes and no, then we will use binary regression problem. For example, we have a data set where it is given that numbers of hours of study and result pass fail pass fail pass fail. So you can input the number of hours of study and get the result in either pass or fail. Okay, so out of 10 features, 4 features, 3 features, or 2 features, the outcome, the target is yes and no. Okay, you have a certain budget, you plan to buy a car. Okay, now you decide the car, the after sale value, okay, repair, maintenance, make it 4 features, and then you take a decision to buy certain model of car. Yes and no, yes and no, yes and no, yes and no. So whenever you have a problem like this, you always use logistic regression. Okay. So now the first and the foremost thing that comes to mind is that we have a simple regression model, so then why we need a logistic regression model? Now this slide answers this question. So what happens is that regression model continuous value, linear regression model, the continuous value, it uses a continuous values and is unsuitable for classification because it can output values beyond the range of 0 and 1. That is, in regression you can have a value greater than 1, okay, which are not meaningful for the classification. It is sensitive to outliers which can distort the decision boundaries. It does not model the probabilities directly. So 3 factors are there. The first one is that the output of linear regression can exceed the value 1, which is meaningless in case of probabilities, because maximum probability can be 1. And the third thing is that it is sensitive to outliers. To address these issues, the logistic regression applies a transformation to map the outputs into the probability range of 0 and 1. So when you are mapping the probability range between 0 and 1, so that becomes the logistic regression. Okay. Now you see that whatever we talked about in the previous slide, this graph presents that. So let's say you have certain outputs, targets, which are classified as no, so they are on the value 0. So all the x are marked on this line. And there is a certain threshold for a problem. Above that, you mark every point as x. Okay. So in this particular graph, here is a threshold value is 0.5, which means the value of h of x, that is a function, greater than 0.5, then we can predict the malignant tumor. So malignant tumor means 1. Okay. If it is less than 0.5, then we predict the benign tumor. That is, it is not a dangerous thing, not a fatal issue. Okay. So that we can do it. And this graph actually represents the logistic linear regression. Now coming to the next point, you see this point x, which is above the threshold, but it is completely an outlier kind of thing. So add some outliers in our data set. Now this best fit line will shift to that point. So instead of crossing to the center of these 4x, okay, it has now shifted towards the another x, which is certainly an outlier. Suppose the number of outliers are increased, so this line will become more flat. That is, the m value for this line, that equation of line is y equals to mx plus c. So the m value will decrease. Okay. So we can have, due to the potential outliers in the data set, we will have this line, and it can reach to certain values which are just on the boundary of thresholds. Okay. Okay. So the blue line represents the old threshold, and the yellow line represents the new threshold, that is 0.02, this is 0.05. To keep prediction right, lower the threshold value. So outliers are increased, so to keep the prediction right, we have to actually decrease the threshold. But there is certain limit to which we can decrease the threshold. Okay. So hence we can say that linear regression is prone to outliers. Okay. Now, what will happen if hx is greater than 0.02? Only this regression will give the correct output. Another problem with the linear regression is that the predicted values may be out of range. That is, it can give values more than 1. The probability can be between 0 and 1, but if we use linear regression, this probability makes it to 1 or go below 0. To overcome this problem, we use logistic regression, which converts this straight line, best fit line, in a linear regression to an S-curve. S-curve is, S stands for sigmoid, and it actually makes a shape of resembling S. Using this sigmoid function, which will always give the value between 0 and 1. So if we use this sigmoid function or S-curve, so we can map that value between 0 and 1. So this solves our problem. So there is a comparison. You see that in a linear regression we will always get the straight line. Okay. Now if we convert this linear regression to the logistic regression by using sigmoid function, we have something like S curve. Okay. So this is principally a sigmoid function. Okay. On the basis of these categories, the logistic regression can be classified into 3 types: binomial, multinomial and ordinal. So in binomial, what happens? you have you have a classification problem where the outcomes can be between 0 and 1. Okay, yes and no. Multinomial classification is that you will stay in the same class, but there are divisions within the class. Like for example, you are actually recognizing something, predicting something like animals, okay, pets. But inside that, there's a category called cat, dog, or sheep. Okay, and that is multinomial. That is the class, the overall class features mapped to some common point. In this case, they are all animals. Or you can simply, for the simplicity, you can assume that these are pets. So cat can be pet, dog can be pet, and a sheep can be pet. Oh, okay. So the general class is a common feature. We have a common feature. In that common feature, there are certain division. And ordinal means low, medium, high. That is, division is based on certain values, certain mathematical values, certain limits that we have low, medium, high. Or okay, what is an expectancy of buying a house? Okay, by a customer. So we can have an expectancy of low, medium, and high. Okay, so that is ordinal. So keep in mind what is multinomial and ordinal. Okay. So assumptions of logistic regression. So this will, after completing this, our foundation base is clear. So each observation is independent of other, meaning there is no correlation between any input variable. So the first data point or the first record in the data set is independent of second. Okay. So each observation which you made for certain feature is independent of other. Binary dependent variables, it takes the assumption that the dependent variable must be binary, okay, or dictonymous, meaning it can take only two values. Okay, for more than two categories, softmax functions can be used. I have told you that if you are doing predictions by using logistic regression, and we have more than two classes to predict, so you can use advanced functions like softmax. Okay. So linearity, relationship between independent variables and log of odds. So the relationship between independent variables and the log of odds for the dependent variable should be also be linear. It cannot be non-linear. So this is the third assumption. Fourth assumption, it assumes that there should be no outliers in the data set. Although this can handle the outliers very well. Okay, but we assume that they are removed earlier in the pre-processing step only. Large sample size. Okay, so the sample size is sufficiently large. That means you need a huge amount of data, large amount of data to actually make correct predictions. Okay, so these are the assumptions of logistic regression. Okay, so that's all in the theory base of logistic regression. The foundation for logistic regression has been discussed, and in the next lecture, that will be probably the logistic regression 2, we will continue this topic. Thank you.